Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we are computing variance and standard deviation from individual data. So let's start the lecture. Variance and standard deviation from individual data. Now we are computing variance and standard deviation from individual data. So for this purpose, we are taking a numerical example. So let's take the numerical example. Suppose we have a data set. The data set has been denoted by X and it contains 1, 2, 3, 7, 8 and 9 as data points or the values of the variable. And now we are computing variance from this data set. So for this purpose, we will proceed as. Now for computational purpose, we are writing this dataset vertically. Now as I have already told you in the previous lectures that in statistics, the first step in the computation of any numerical problem is to write the corresponding formula. Suppose this dataset is a population data. So for this purpose, we will write the formula of the population variance. So the formula of the population variance is sigma squared is equal to summation x minus mu whole squared divided by capital N. Now if we focus upon the formula, so within the parentheses we have x minus mu. So we have already x as it has been given, but now we need mu, which is the population mean. So first of all, we will compute mu. By definition, mu is equal to summation x over n. Now summation x means total of the values of x. So if we add all the values of x, it will give us 30. So now for summation x, we will write 30. And this n stands for the number of data points in that data set. So if we count the number of data points in this data set, so they are 6. 1, 2, 3, 4, 5, 6. So we will write 6 over here. And if we simplify, so we will get 5 is the population arithmetic mean. So now this is the population arithmetic mean. The next step is to subtract mu from x. It means that we will subtract this mu from each value of x. Means we will subtract 5 from 1, then we will subtract 5 from 2. Similarly, we will subtract 5 from 3 and so on. So the next column will become x minus mu. So this column is now x minus mu, means 1 minus 5, 2 minus 5, 3 minus 5 and so on. And now we will simplify this column. So if we simplify this column, so we will get, so now we have obtained deviations. These are deviations. As I have already told you that deviation is the difference of two numbers. So 1 minus 5 is equal to minus 4. So this is the deviation of these two numbers. Similarly, 2 minus 5 is equal to minus 3. So this minus 3 is the deviation of 2 and 5 and so on. Now again, if we focus upon the formula, so next we need to square these deviations. So the next column will become x minus mu square. So this will become 16, 9, 4, 4, 9, 16. So now these are the squared deviations. Again, if we focus upon the formula, so in the numerator we need the total of the squared deviations. So it means we will total this column. So if you total this column, so symbolically it will give us summation x minus mu square, and if we add them also, it will give us 58. So this will give us 58. Now whatever is needed in the numerator of this formula, we have obtained that over here. So now we will put 58 for summation x minus mu whole square in this formula. So this will become 58. Now in the denominator, n stands for the number of observations. So in this case, the number of observations is 6. So now we will put 6 over here. And if we simplify, so we will get 9.33 in unit square as the answer. So when we simplify 58 over 6, so we got 9.33 unit square. This stands for the unit square. Whatever unit this variable contains will be squared. So finally, sigma square will become 9.33 unit square. So this is the final answer, and this is the population variance. Okay, now to compute the standard deviation, simply we need to take the positive square root on both sides of this equation. That is, we will take square root over sigma square and we will take square root over 9.33 units square. That is, sigma square will equal to, now we will take square root on both sides. That is, we will take square root over here and we will take square root over here. So in the next step, this 2 and this root will be cancelled out. So this will become sigma. And if we simplify this, so we will get 3.5 something. And this units, this square will be cancelled out with this root. So this will become simply unit. So now this is the standard deviation. So now we have computed the population variance and the population standard deviation from this dataset by the basic formulas. As I have already told you in the introductory lecture related to variance and standard deviation, that they are interrelated. That is, variance is the square of standard deviation, or standard deviation is the positive square root of variance. So over here we have computed variance, which became 9.33. So when we took the square root of this variance, so we have obtained the standard deviation. So on the basis of their interrelationship, we can obtain one from the other. Now the computation of the population variance and the population standard deviation have been completed over here. This is enough for the computation. But these computations have been done on the basis of basic formula of the variance and standard deviation. Now we can obtain the same quantities by the derived formula from this basic formula. So let's try that too. So we are writing this dataset again. Now first of all, we will write the derived formula for the population variance. That is, sigma square will equal to, now this is the derived formula of this basic formula for the population variance. Okay, now if we focus upon this formula, so first of all we need summation x square in the numerator of the first fraction. So for this purpose we will square x column, means we will square each value of x. So in the next column we are writing x square. Now this summation x square mean total of x square. So if we add this column, so it will give us summation x square. So symbolically it will give us summation x square. And if we add them also, we will get 208. In the denominator of the first fraction, this stands for the number of observations. So the number of observations in this case is 6. So we will write 6 over here. Now in the second part of the formula, in the numerator of the second fraction, we need summation x. So it means we will add x column. So if we add x column, so symbolically it will give us summation x. And if we add all these values, so it will give us 30. Okay, now we have all the quantities which are needed for this formula. Now we will put the numerical values in this formula. For summation x square, we will put 208. And for n, we will put 6. Minus, for summation x, we will put 30. And divided by n, for n we will put 6 and we will square it. Okay, in the next step we will simplify it. So 34.33 minus 25. So finally we will get sigma square is equal to 9.33 and units square. And hence this is the final answer of the variance. And this result is exactly the same to the result obtained from the basic formula of the variance. So hence both of the formulas give identical result. And similarly for standard deviation, we will take positive square root of this variance. So this will give us sigma is equal to 3.5 unit, which is again exactly equal to the standard deviation obtained from the basic formula of the variance. If we compare both of the procedures, so both of them are giving the same results. But in the first procedure, we need the arithmetic mean of the dataset. After obtaining the arithmetic mean, then we need the deviations of the observations from the arithmetic mean. And after getting the deviations, then we need the squares of each of the deviations. And finally, we need the total of the squared deviations. And after that, we will plug the values in the formula to get the result of the variance. But in the second procedure, we need only one extra column, that is x squared. We don't need the computation of the arithmetic mean first. Without the computation of the arithmetic mean, we are able to compute the variance by the second procedure. So that is why, as I have already told you in the introductory lecture related to variance and standard deviation, that the second procedure for the computation of variance or standard deviation is easier. So that is why in practice this second procedure is used frequently. So now one point to note is that whenever you are computing variance or standard deviations, so you should follow only one of the procedures, that is the first one or the second one. You don't need to obtain the variance by the first procedure as well as by the second procedure. If you have followed the first procedure and you have followed these steps, and finally you got an answer. So that is enough. You don't need to compute the variance again by this procedure as well, because you have already computed it by the first procedure. Or if you have computed the variance by the second procedure, so you don't need to compute it by the first procedure because you have already obtained it by the second procedure. But why I have computed the variance by both of the procedures, it was only to convey you the difference between these two procedures and the ease in the computation by the second procedure. So that is why I have computed variance by both of the procedure. But you people don't need to compute it by both of the procedures simultaneously. By any one of the procedure you can compute the variance. So this should be remembered. So this was all about the computation of variance and standard deviation from individual data. I hope this will help you in the computation of variance and standard deviation from individual data. Thank you for watching the video.